the factory that builds the machines that keep cities moving. So you want to own a garbage truck factory. Every morning, while most people are starting their day, thousands of garbage trucks are already moving through cities. They stop outside homes. Workers load waste into the truck. Hydraulic systems compress it. The vehicle moves to the next street, and eventually everything is transported to a landfill, recycling facility, or waste processing plant. Most people barely notice these trucks, but behind every one of them is a surprisingly complex industrial business. A garbage truck isn't simply a normal truck with a large container attached to the back. It combines a heavy-duty commercial vehicle with hydraulic systems, automated lifting equipment, compaction machinery, electronic controls, specialized bodies, and safety systems. And because municipalities and private waste companies depend on these vehicles every single day, reliability is critical. A truck that breaks down doesn't just create an inconvenience, it can interrupt an entire waste collection route. You're not manufacturing a vehicle people buy because they want it. You're manufacturing a machine cities and waste companies need to keep operating, and that creates a very different economic model. So what would it actually take to own a factory producing thousands of garbage trucks every year? Let's break it down. Which garbage truck factory are you buying? Let's imagine we're building a large manufacturing facility capable of producing 5,000 garbage trucks per year. That's a substantial operation. The factory would need steel processing equipment, truck body fabrication areas, welding station, hydraulic assembly system, painting facilities, electrical assembly, final vehicle assembly, testing areas, parts warehouses, and a large outdoor yard for completed vehicles. But unlike a normal truck factory, the manufacturing process is highly specialized. The factory isn't simply assembling an engine, cab, and wheels. It has to integrate a complete waste collection system onto the vehicle. That means hydraulic cylinders, pumps, valves, compactors, lifting mechanisms, control system, storage bodies, and specialized safety equipment. A garbage truck factory is really two factories working together. One builds the vehicle. The other builds the machine that handles the garbage. The first $500 million. Now imagine building a large modern garbage truck manufacturing operation requires approximately $500 million in capital investment. The actual amount could vary significantly depending on production capacity, location, automation, vertical integration, and how many components are manufactured internally. But $500 million gives us a useful model. That money goes into the factory buildings, welding equipment, steel processing machinery, paint shops, assembly lines, hydraulic testing system, robotic equipment, warehouses, quality control laboratories, and production tooling. But there's another major expense: working capital. The factory has to purchase engines, transmissions, axles, hydraulic components, steel, electronics, tires, and countless other parts before the finished truck is sold. Imagine another $100 million is tied up in inventory and working capital. Now, roughly $600 million is committed to the operation. The factory doesn't become profitable when it builds the first garbage truck. It becomes profitable when thousands of trucks leave the factory at a price high enough to recover the billions and millions invested in making them. From steel to a garbage truck, now production begins. Large steel sheets enter the fabrication department. They are cut, shaped, and prepared for welding. The garbage body begins taking shape. Structural frames are assembled. Panels are welded together. The hopper is installed. The compaction system is fitted. Hydraulic cylinders are connected. The lifting mechanism is assembled. Then, the body is mounted onto a heavy-duty truck chassis. The engine and transmission provide the power. Hydraulic pumps convert that power into mechanical movement. Electrical systems connect the controls. Safety systems are tested. And finally, the entire vehicle goes through inspection. Every hydraulic function needs to work. The lifting mechanism needs to operate smoothly. The compactor needs to handle heavy loads. The doors need to close properly. And the vehicle has to survive thousands of repetitive cycles. A garbage truck may spend its entire working life doing the same thing. Stop, lift, dump, compress, move, repeat. The factory has to build it to survive that cycle thousands of times. The chassis cost problem. One of the biggest costs is the truck chassis itself. A garbage truck needs a heavy-duty commercial platform capable of carrying significant loads. That means a strong frame, powerful engine or electric powertrain, heavy-duty axles, brakes, suspension, wheels, tires, transmission, and electronics. Imagine the chassis and powertrain account for approximately $150,000 per truck. At 5,000 trucks per year, that's $750 million worth of vehicle platforms, and that's before adding the garbage collection equipment. The garbage truck body may get all the attention, but underneath it is a commercial vehicle that already represents a huge portion of the final cost. The hydraulic system problem. Now we reach one of the most important systems. Hydraulics. Garbage trucks use hydraulic power for many functions. The body may lift, the hopper may move, the compactor may operate, the container mechanism may raise heavy loads, and all of that requires pumps, cylinders, valves, hoses, reservoirs, and control system. Imagine the hydraulic system costs approximately $25,000 per truck. At 5,000 trucks, that's $125 million annually. But reliability matters more than simply cost. A hydraulic failure can take an entire garbage truck out of service. And if a waste company operates hundreds of trucks, repeated failures can become extremely expensive. In a garbage truck, hydraulics aren't an accessory. They're the muscles of the machine. The cost inside every truck. Now let's build a simplified economic. Imagine the factory produces 5,000 garbage trucks per year. Suppose the average selling price to a customer is approximately $300,000 per truck. That creates approximately $1.5 billion annual revenue. But the manufacturer doesn't keep $300,000. The chassis money, hydraulics cost money, steel costs, electronics cost money, tires cost money, labor costs money, paint costs money, testing costs money, and transportation costs money. Suppose the average direct manufacturing cost is approximately $230,000 per truck. At 5,000 vehicles, that's $1.15 billion. That leaves approximately $350 million before additional operating expenses. Now subtract research and development, administration, warranty, financing, sales, depreciation, and factory overhead. The final profit can be dramatically smaller. A $300,000 garbage truck doesn't mean the manufacturer makes $70,000 in pure profit. The margin only becomes real after every expense has been paid. The labor and engineering problem. A garbage truck factory needs skilled workers, welders, machinists, hydraulic technician, electrician, engineers, quality inspector, assembly workers, maintenance technician, and production. But specialized vehicle production still requires significant human involvement. Imagine labor and engineering related expenses total $100 million annually. At 5,000 trucks, that's approximately $20,000 per vehicle. That is a significant cost. But skilled workers also create value. A better welding process can reduce defects. A better hydraulic design can reduce warranty claims. A better assembly process can reduce production. The cheapest worker isn't necessarily the most profitable worker. The profitable worker is the one who helps produce a reliable truck with fewer problems and less waste. The automation advantage. Modern garbage truck factory can use automation in many areas. Robotic welding can produce joints. Automated cutting systems can process steel. Painting systems can apply coatings. Computer-controlled machinery can create precise components. And digital systems can track production. Suppose automation reduces manufacturing by $5,000 per truck. At 5,000 trucks, that's $25 million per year. But automation requires investment. Machines have to be purchased, installed, programmed, maintained, and eventually replaced. The goal isn't to automate because robots look impressive. The goal is to automate the repetitive work where consistency and lower costs create measurable economic value. The production volume game. Now imagine the factory has $150 million in annual fixed costs. At 5,000 trucks, that's approximately $30,000 of fixed cost per truck. But what happens if production increases to 7,500 trucks? The same fixed costs become approximately $20,000 per truck. That's a $10,000 improvement in fixed cost allocation. Across 7,500 trucks, that's enormous. This is why factory utilization matters. The more efficiently the plant operates, the more cheaply it can spread its fixed costs across every vehicle. But there's a limit. You can't simply build trucks faster if customers aren't buying them. The municipal customer problem. A major customer base for garbage trucks is municipal government. Cities need waste collection vehicles. Budgets have to be approved. Contracts have to be awarded. Specifications have to be met. A factory might have the capacity to produce thousands of trucks, but the customer may not order them immediately. The factory controls production. It doesn't control when a city decides to spend its budget. That makes demand forecasting extremely important. The private waste company problem. Private waste companies are another major customer. These businesses operate large fleets. They need reliable vehicle. A truck that costs $20,000 more but lasts longer and spends less time in the repair shop may actually be the cheaper option over its lifetime. For a waste company, the cheapest truck isn't necessarily the truck with the lowest purchase price. It's the truck that produces the lowest total cost over years of operation. That gives manufacturers an opportunity to compete on reliability rather than price alone. The electric garbage truck transition. The industry also changing. Electric garbage trucks are becoming increasingly important as cities and waste companies look for cleaner transportation options. Electric powertrains can eliminate traditional engine systems. Large battery packs, high voltage charging infrastructure, battery management system, and specialized technicians. That means manufacturers may need to invest heavily in new production capabilities. The garbage truck of the future may still collect the same garbage, but a technology underneath it could be completely different. That creates a major investment opportunity and a major risk. The battery cost problem. For an electric garbage truck, the battery can become one of the most expensive components. Imagine the battery system costs $100,000 per vehicle. At 5,000 trucks, that's potentially $500 million worth of battery. If battery prices fall, manufacturers can improve margin. If battery material prices rise, costs increase. And if battery technology changes quickly, today's manufacturing equipment may need to be upgraded. The transition to electric garbage trucks isn't simply a technology change. It's a financial decision involving hundreds of millions of dollars in equipment, inventory, and engineering. The maintenance and warranty problem. Garbage trucks operate in harsh conditions. They stop and start constantly. They carry heavy loads. They operate hydraulic systems repeatedly. And they can work in rain, heat, dust, and freezing temperatures. That creates enormous wear. If a manufacturer builds unreliable equipment, warranty claims can become expensive. Suppose warranty and service-related costs average $10,000 per truck. At 5,000 trucks, that's $50 million annually. And that's before considering damage to the brand. The real cost of a defective garbage truck isn't just the repair bill. It's the downtime and the loss of customer trust. The supply chain problem. A garbage truck factory depends on a huge network of suppliers. Engines, transmissions, axles, hydraulic pumps, steel, electronics, tires, seats, lights, control system, and thousands of smaller components. If a critical supplier stops delivering, the factory can be forced to slow production. Imagine 500 trucks are nearly complete. Everything is installed except one specialized hydraulic valve. Those trucks can't be delivered. The factory has already spent millions building them, but the revenue hasn't arrived. In manufacturing, the most expensive missing part may be the smallest part that stops the entire vehicle from leaving the factory. The inventory trap. Now imagine the factory has 500 completed garbage trucks sitting in its yard. At an average manufacturing cost of $230,000, that's approximately $115 million tied up in finished vehicles. That's a huge amount of capital. And unlike consumer products, garbage trucks aren't easy to sell to random customers. They're specialized vehicle. Different customers may require different body configuration, different lifting systems, different chassis specifications, and different technology. A finished garbage truck sitting in a yard isn't profit. It's millions of dollars waiting for a customer. The customization problem. Not every waste company wants the same truck. Some need rear loaders. Some need front loaders. Some need side loaders. Some operate in narrow urban streets. Others handle industrial waste. Some customers want diesel. Others may want electric. That creates a manufacturing challenge. More customization means more complexity. More complexity can increase costs, but too much standardization can make the product less attractive to customers. The factory has to find the sweet spot between mass production and customization. That's where the real manufacturing skill comes in. The ownership traps. The first trap is underestimating chassis costs. The second is ignoring hydraulic system reliability. The third is building too much capacity. The fourth is carrying too much finished inventory. The fifth is depending too heavily on government contracts. The sixth is ignoring private waste companies. The seventh is failing to prepare for electric vehicles. The eighth is underestimating warranty costs. The ninth is relying on fragile suppliers. And the final trap is competing only on purchase price. A garbage truck is a business tool. Customers don't just want a cheap machine. They want a machine that works every day. The factory verdict. So what separates a profitable garbage truck factory from a giant industrial expense? Reliable chassis, efficient hydraulics, strong steel fabrication, high factory utilization, good supplier relationships, low warranty costs, efficient production, and the ability to adapt to electric technology. The smart owner doesn't simply ask, how many trucks can we build? They ask, how much does each truck cost? How much downtime will customers experience? How expensive are warranty claims? How much capacity does the market actually need? And how much profit remains after manufacturing, engineering, service, and financing? Those are the numbers that determine whether the factory succeeds, the real economics. But from the outside, a garbage truck looks like a heavy-duty truck with a giant metal box attached to it. But economically, it's a specialized machine designed around one purpose: moving enormous amounts of waste as efficiently as possible. That creates a surprisingly valuable market. Cities need them. Waste companies need them. Construction companies need specialized version. And recycling operations need increasingly sophisticated collection systems. The factory makes money by combining a commercial vehicle with specialized waste handling technology. But the economics are unforgiving. Steel prices matter. Chassis prices matter. Hydraulic components matter. Labor matters. Energy matters. And production volume matters. Every improvement in manufacturing gets multiplied across thousands of trucks. Save $5,000 per truck, and you could save $25 million across 5,000 vehicles. The most valuable garbage truck isn't necessarily the one that costs the least to manufacture. It's the one that gives the customer the lowest cost over its entire working life. That's the real business. So, is owning a garbage truck factory a license to print money? Not exactly. It's a massive industrial bet on municipal spending, private waste collection, manufacturing efficiency, and the future of transportation. If the factory controls material costs, maintains high production volume, builds reliable hydraulic systems, keeps warranty costs low, and successfully transitions toward electric technology, the economics can be extremely attractive. But if demand falls, inventory builds, supply chains break, or expensive new technology arrives faster than the factory can adapt, those hundreds of millions invested in equipment can become a major financial burden. The most dangerous garbage truck factory isn't the one that can't build enough trucks. It's the one that can build thousands of them, but can't build them cheaply enough, reliably enough, or intelligently enough to keep customers coming back. That is the real economics of owning a garbage truck factory.